एक छोटी आग से बड़ी आग बनती गई, थोड़ी चिंगारी से बड़ी बनती गई.
Arthur Clarke called it the greatest communication experiment in history.
Our drive was to develop the country, educate the country.
Satellites was the best way to reach out to the rural areas with the latest information in the fastest possible manner.
Dr. Vikram Sarabhai was very much convinced that it was definitely possible to use satellite communications for covering the entire country with television.
गांव में टेलीविजन लगाना, 400 गांव का सिलेक्शन करना और इंस्टॉलेशन सबसे बड़ा काम था.
Initially, all the women will come with a ghungat up to almost this place. It is 1 year has brought it to this place. That I think is a very big social change.
Site has demonstrated capabilities of today's broadcasting.
Site was just a beginning of an experiment. The goal was inside.
Site, after an intense preparation of 5 years, began in 1975 for a period of 1 year. The television programs produced for this experiment were broadcast for the first time directly from a satellite to 2,400 villages of 6 states of India.
3, 2, 1, roll video!
आज पहले दफे इतने दूर होते हुए भी मेरी आवाज और मेरी तस्वीर आपके सामने है इस उपग्रह द्वारा.
These programs were watched and appreciated by an audience who had no access to mass media.
Control room calling studio, are you getting me?
Sir, could you please tell me if the spacecraft is configured for sight at this time?
In 2015, SITE celebrates its completion of 40 years since its launch. As a tribute to all those who participated in this experiment, we present to you a glimpse of that era.
The fact that there were people who visualized that such things could be done, the fact that there were people who could convert that visualization into practical experiments, the kind of innovative approaches that they adopted, and the kind of experiments that they planned. It is good to tell this story today to the current generation.
You know that we are going to have for the first time the experiment to have direct broadcast of television from satellites which can beam high power to a restricted region in the territory of India.
See, if you have to think of sight, the conception of sight, you have to go back to the India of mid-60s. We were still importing food and our population was increasing at a high rate. And therefore, communication and information was considered to be a very important input in the process of development of the country.
So, importance of communication was realized to reach students in villages spread over 6 lakh villages.
Particularly in a country like India where the large mass of people who have to be motivated are illiterate. It is very important to, I think, have the information input as an integral part of the developmental process. And I think a powerful technique like a audiovisual presentation through television can be one of the most important motivations, a catalyst for action.
Second and third letter describes what sight is. Instructional television, of doing various developmental messages, hygiene of people, little bit of agriculture, little bit of animal husbandry. So the things which will be of day-to-day use for people to learn and then do. So it was basically a developmental communication.
Especially for fields like agriculture where you want to show them things, television was a great medium. But how do you take television out to remote areas? That is where the satellite and space technology came in.
When Chitnis had gone to USA at that time, they were talking about, why are you conducting site? Go directly for INSAT. Why do all this particular thing? But we had to have that experience with us.
And our system studies indicated that we could do that at 1/3 the cost of conventional microwave technology or cable, and well before 2000. We can bring it by 1980 or so.
November, December 1968, it became clear that we were proceeding with carrying out two system studies. One was to be carried out at GE and another was to be carried out in Hughes aircraft, General Electric study, which defined our total system and the total system cost to a certain extent. 1970, we conducted one additional study, and this was done by ISRO and MIT. And there we concentrated only on the satellite, not on the ground system. They were also looking at using the additional payload, that was the spin scan camera, which was being utilized by that particular time on the one of the earlier ATS-1 and ATS-3 satellite also, such that we could use it for photographing the Earth and looking at the cloud cover from geosynchronous altitude. And that was something really fantastic, the kind of thing which was coming up. And so we knew that in which direction as INSAT our system would really come up.
And so in India, in our cultural context, will television have an impact at all? How do we know that we can use television for agriculture, for example? So he said, look, can we use the Delhi TV station to mount a small controlled experiment to see that if we mount agricultural programs, does it have an impact on the farmers? So that is how Krishi Darshan was initiated. It was not just to see that is television effective for agriculture, but how do you make it effective for even the small farmer? The small farmer could not afford a TV set. The concept right from then came of a community TV set, placed in a common location where all the villagers would come. And that is how Krishi Darshan began.
We had 10 resident engineers in NASA when ATS was being built at Fairchild. So they would go for reviews. They would make suggestions. ये ऐसा क्यों है, वैसा क्यों नहीं है? And then NASA used to accept their suggestion and make changes and make satellite better.
I was working on the ATS satellite. Everything about satellite technology, advanced technology, I learned there.
On the ATS satellite, for the first time, they were going to carry a large 30 feet diameter dish or 9.5 meter diameter dish. As against the other satellites in those days, the satellite antennas were hardly something like maybe 2.5 feet to 3 feet in diameter.
See, in preparing for site, there was a large number of activities to be done, both on the hardware side and on the software side. On the hardware side, you had to first upgrade the earth stations. You had to build the studios. And you had to indigenously develop the direct reception system. So the antenna, the front end and the rear end converter and the television set, all these had to be developed, integrated and tested.
Because remember, this was not operating in some nice sophisticated air conditioned environment. It had to operate in villages where there's high temperatures, dust. It had to be taken to the village on bad roads, so you had to go through a vibration test and bump test. So we went through all the tests and then it had to be mass produced.
Here, the whole idea was reversed. Put all the power on the satellite so that the village can be very simple. And also, what an engineer would not like to do is to make holes in an antenna. Because all the holes in an antenna means you are losing the gain of the antenna. This was chicken mesh.
Yes, this is a chicken mesh. The accuracy can be much less than in that antenna where you're working with 6,000 megacycles.
For the direct receiving set, the low noise amplifier was to be designed here and built here. Few of those component sets were built, this head end, which is mounted on top, and they were sent to NASA. We had a person there for testing. We had tested them, and back came italics from, I think, Rajan. He says they have tested it, they say they are terrible. They have no temperature stability, they won't work. You better send the engineers to NASA and they'll learn here and then learn to design. And so I sent a telex back to NASA saying, no, I'm not sending my engineers there. We'll have a new design and it'll come there. And this design was done, it was presented, it was approved, the new units were built and 6 were sent and came back. The telex said, they are wonderful, they all work fine.
The receiver required the low noise amplifier and the converter to be kept very close to the antenna, and the antenna would have to be outside. And inside the television set or near the television set will require an additional tail end unit so that the signals will come up to that particular place. They will get demodulated and will get into our television set. It was decided that we will use this ECL TV set because that was the only solid state TV set that was available, and that too it was of a 23 inches in diagonal. So that was the largest available. Our biggest problem always was fluctuations in the electricity, and due to that the fault propagation, because once the electricity creates a problem, goes over voltage, it could create a problem in the television set also. So that was the thing which had to be really sorted out in terms of much wider range for the regulators and all other things. In Orissa, we had to also have an experiment within experiment, and that is, out of the 400, I think more than 150 or so, as far as I recall the number, were battery powered.
Then you had to set up the uplink station. Again, we had a station which dated from earlier days, which was used for telecommunications. Had to be modified, changed, and we did that. Then we did a TV studio for sending all the programs up. So we set up one in Ahmedabad.
हमने टेलीविज़न स्टूडियो की बिल्डिंग बनाई और वो बिल्डिंग भी बहुत ही अच्छी और सोच समझ के बनाई गई, जिसमें प्रोग्राम जनरेशन कैपेबिलिटी हो और प्रोग्राम ट्रांसमिशन के। बॉम्बे स्टूडियो भी हमने एस्टेब्लिश किया, प्रोग्राम प्लेबैक के लिए यूज किया गया अहमदाबाद का, और बॉम्बे स्टूडियो में एजुकेशन प्रोग्राम बनाने का था।
We decided to set up an uplink station in Delhi. Delhi, because we thought there would be many advantages for television programs. If there was something live happening in Delhi as the national capital, we could use that too.
Pant and Chitnis traveled all over Delhi. We wanted to set up one earth station in Delhi. My God, they must have found all kinds of places to try to find a place which not noisy, where they could set it up. Finally, they located a place which is in a forest area, Malcha Mal.
Incidentally, that was commissioned in good time, just a week or two before the launch of site. But we managed to meet the deadline, get it tested, checked out.
हमारी टीम और इंजीनियर्स ने बहुत सारे वीडियो ब्रॉडकास्ट इक्विपमेंट बनाए, जिसमें डिजिटल टाइम बेस्ड करेक्टर एक बहुत इंपॉर्टेंट इक्विपमेंट था। ये डिजिटल टाइम बेस्ड करेक्टर के द्वारा छोटे वीटीआर के इक्विपमेंट के प्रोग्राम को हम स्टेबल कर ब्रॉडकास्ट कर सकते थे। वर्ल्ड स्टडी की हम लोगों ने एंड डिसाइड किया कि हम 1 इंच वीटीआर यूज करेंगे। 1 इंच वीटीआर बहुत इकोनॉमिकल था और बहुत ही उसकी टेप ट्रांसपोर्टेबल थी। ये नई टेक्नोलॉजी थी और इस नई टेक्नोलॉजी को हम साइट ट्रांसमिशन के लिए लेके आए।
Site also brought quite a few experiences, quite a few things which we learned out of it as to how to manage with in a single transponder. To get the second language, we had to have a second sound subcarrier kind of a thing. And yes, we did have certain programs which were produced in Kannada and Telugu separately and brought together in 2 languages. During site, we conducted an experiment for using injected carrier in a transponder, such that when the television signals are going on, there is another signals are also present. We utilized that kind of signals for our entire radio networking. We utilized those types of signals for our disaster management system.
It was decided that we will select the states on the criteria of backwardness and also the districts on the criteria of backwardness. Therefore, those states which had the highest number of backward districts were selected. And then from within the state also, the most backward districts we tried to select. And that is how we identified 6 states and 4 districts in each state. So about 24 districts, and each district would have about 400 TV sets, so that we will have a total of 2,400 TV sets. We wanted that the district headquarters would be the maintenance center, and the village should not be more than 100 kilometers away. And you made a circle, and we selected villages only from within that circle. In the villages, we selected the school buildings. Now, most of the school buildings, almost 90% of them, did not have electric connection.
And we had to actually came up with the idea of the Operation Electricity, where for each location we had to send, for each state, one engineer from ESD and our systems engineering group. Their job was to get electricity to those particular places, but without any expenditure of money. They had no money. They are just only the persuasion of the state government people and the electricity people and all other people.
The responsibility of the pupil in cluster was what at that time was known as DOME, deployment, operation and maintenance.
How do you align an antenna and all other systems when the signal itself is not there? We had to first of all determine the north direction and therefore the direction to which we were going to look at, because the satellite location was known. So using the sun as the reference, we developed a technique to find out which is the exact north direction.
And we had predestined maps and all, installed the TV sets in the villages, and they were, as you might have seen the photographs and all, 10-foot chicken mesh antenna. Each antenna had about 192 screws and nuts. Now imagine a person is screwing 192 nuts in each antenna. Now our team sometimes installed 4 to 5 antennas per day. Plus there must be somebody ready to take the charge of it, either Sarpanch or the school teacher. Finally it was decided the school teacher will take care of it.
Site teachers, कभी टीवी देखा ही नहीं था, उनको सिखाना पड़ा कि टीवी चालू कैसा करना.
अगर कहीं से कंप्लेन आया तो उसके लिए एक पोस्ट कार्ड सिस्टम था. टीचर को सिर्फ लिख देना है आवाज नहीं आती है, लाइट आती है या दोनों नहीं है. हमारे पास 20-30 आदमी का टीम था टेक्निकल, 4 जीप. ये लोग रेगुलर विजिट करते रहते थे.
Once or twice it also happened that one of our teams thought they could not repair a TV set in the villages, so they had to take it back to the lab and bring it back. There was a bit resistance that no, you do it here, don't take it back.
One is the major responsibility of program production was with Doordarshan for all the site clusters, and they had set up 3 base production units for producing these programs.
We had our own ideas about what the educational television programs should be.
2-3 हफ्ते तो मेरी इतनी बुरी हालत हुई दिमाग में कि what the hell have I come into? How do I get this science program made? And suddenly it occurred to me. One night I wrote down and brought and showed it to Chitnis and Kiran and so on. As I made a credo. Kya credo? I said the credo is,
the objective is to make children realize that science is everywhere.
The one line that will stick in everybody's mind is that this is an exercise not in planting trees, but in planting seeds, in sowing seeds. Because the seed will grow. This is for young children to grow into a tree.
I wrote a letter to all my friends who were interested in science education, including Professor Philip Morrison of MIT and many others. We have this problem. We have to make science programs, and we have made this credo. We hope you agree with this credo, but we need some briefs for the programs. So 2-3 weeks later, I got a letter from Philip and Phyllis Morrison. Here are 100 briefs for the programs you want to make. We admire your idea.
We set up a small studio in Bombay, now Mumbai, with help from the municipal corporation, which gave us an old disused part of a municipal school. We converted that into a small studio, very small studio in Mumbai. In Ahmedabad, of course, we had to establish a studio because of need for uplinking.
Morning programs, of course, was much better run. Reason was that that literature sent to their school teachers before the program, through which they can explain to the children what is going to be transmitted. Then they showed the program, then they asked the question, ran very well. There was no issue on that. But evening programs also ran very well.
In 6 different villages, 6 anthropologists were sent out, I think 6 months before site. They lived there. They lived throughout the site that 1 year and about 6 months later. And by actually being there in the village during this particular thing happening, they were able to come up with the proper records of each one of those particular things.
We had developed or conducted some research to develop audience profiles, to do some needs assessments, make some pilot programs and do the pre-testing to see how effective these are and what changes we need to make in the pre-testing of programs.
We also had a small utilization team that tried to see when the programs are broadcast, what do we need to do by way of follow-up activity to make sure that actions happen. You say, you need to take a vaccination for your children. Then how do you galvanize and mobilize the village community to go and do that?
Many of them have not even heard a transistor radio. So you can imagine the reaction to them, what has happened to them the first time they see the program. And villagers' response was very good. Initially they came only in trickles, 10, 5, 15, but when they learned from out there, everything is going well. A lot of people started coming. You will always go to the village, there were a lot of women used to come in the evening and men used to sit on side.
Imagine this, a villager who has never seen a moving picture in his or her life. Suddenly he sees television there, for them it's a magic box. And how they adapt to that technology, how they make it their own, how they take it on.
साइट अगर 9 बजे खत्म होती है रात में, देखिए तो दूसरे गांव से औरत मर्द लोग आते थे टेलीविजन देखने को, और वॉलेंटियर लोग बोलते थे कि कल आपकी गांव का है, कल दूसरे गांव का.
Few villagers complained to us that these children have been taught so much in the village about hygiene that now it has become difficult for us to sit at home, because they say wash your hands before take your food, cover the food, don't leave it open, flies will come, sleep with mosquito net.
संख्या के दृष्टि से स्वास्थ्य के क्षेत्र में उपलब्धि काफी सराहनीय थी. स्त्रियों ने पुरुषों की अपेक्षा ज्यादा लाभ प्राप्त किया. इलिटरेट लोगों ने लिटरेट लोगों की अपेक्षा ज्यादा लाभ प्राप्त किया.
It showed to the country and it showed to the government that satellites can work and that they can be used to carry information to the whole country. Immediately after site, the whole national network was set up and redistribution system was set up. More than 300 terrestrial transmitters were set up by the government within a year, and a complete national network came up.
And then of course INSAT itself grew and changed. From just television it became telecommunications also, and then we added on meteorological package satellites, it became a multi-purpose satellite.
The concept of DTH in a way was demonstrated during this particular experiment, because for a very large number of villages we were able to set up the antenna systems, and that from antenna to the television it was connected, and the concept has evolved by going in from higher and higher frequency bands where the antenna sizes have shrunk from a large few 3 meter, 4 meter diameters to down to less than a meter, or about 0.6 meter or even 0.3 meter antennas today. So in terms of concept, I can still say it is the forerunner of DTH type of services that today is in practice.
बहुत सारी टेक्नोलॉजी जो डेवलप हुई साइट में, उसको आगे चल के यूज किया गया है. चाहे अर्थ स्टेशन की टेक्नोलॉजी हो, स्टूडियो की टेक्नोलॉजी हो, या ट्रांसमिशन की टेक्नोलॉजी हो, उसका जो है भूमिका और उसका बीज साइट में बोया गया था. जो श्रीहरिकोटा में इसरो को जो इसरो का लॉन्च सेंटर है, वहाँ सीसीटीवी की बहुत ज़्यादा ज़रूरत थी, और उसके लिए हम लोगों ने जो इक्विपमेंट बनाए थे उसका नो हाउ हमने इंडस्ट्री GCEL कंपनी को ट्रांसफ़र किया, वहाँ से इक्विपमेंट बनवाया, और वो सब इक्विपमेंट हमने श्रीहरिकोटा CCTV के लिए लगाया. बैंडविड्थ कंप्रेशन और बहुत सारी नई टेक्नोलॉजी जो आज आप देख रहे हैं जिसके कारण ये सब ब्रॉडकास्ट पॉसिबल हुआ है, वो भी हम लोगों ने उसी टाइम डेवलप करना चालू कर दिया था.
But we understood the complexity that it was not just an experiment in doing satellite uplink, downlink. It was much more of a complex sociological aspects are involved, how to communicate to people. So now you have got a digital, you can half frame and all, lip sync is no problem. But in those days we said that as engineers we can give solution for 5. But we found that is not enough because the program making is much more complicated.
तो आज आप टेलीविजन बूम देख रहे हैं, आप इस चैनल का बूम देख रहे हैं, ये सब सैटेलाइट का ही, साइट का ही उपलब्धि का परिणाम है.
Secondly, it spawned a huge industry. Its contribution to our economy. It was no longer a TV is a medium of reading a news. It is a medium for entertainment, education, and message dissemination.
But I think as the experiment took off, the world looked on it, I must say, with what I would call awe. They were saying, my God, India has done this first. Later it became, my God, this is fantastic, what can we learn from this? For the first time, for the common man, how space technology helps. It suddenly struck home. And that too in a poor and developing country like India.
The first time such experiment or such a scale has been carried out in mass communication anywhere in the world, particularly satellite communication.
So I think this was an important, milestone, not just for India, but for space technology across the world. So one of the evolutions of SITE was, of course, the school education programs that came about. Other evolution was the country-wide classroom, and then IGNO and distance education and how it's used.
टेली एजुकेशन, टेली मेडिसिन प्रोग्राम जो इसरो के हैं, उसका बीजारोपण साइट के दौरान हुआ और 2003 में हमने एजुसेट प्रोग्राम को लॉन्च किया. करीब 26 राज्यों में और 3 यूनियन टेरिटरी में 83 इंडिपेंडेंट नेटवर्क्स और करीब 60,000 टर्मिनल्स की स्थापना करी. टेलीमेडिसिन के क्षेत्र में करीब हमने 400 टर्मिनल दूर दराज के इलाकों में स्थापित किए.
Even today, there are still a large number of areas in the country which are not easily reachable, whether it is terrestrial communication or even broadband connectivity, what is there. And then beyond that, we still have many tribal regions and then remote hilly regions where the impact of connectivity through the satellite, in addition to providing just direct broadcast, it can also provide interactive communication. And if interactive communication can be provided, it can still be a very good experiment in the immediate future.
Now, first is that communication revolution itself has taken place. Now, again ask the question, what is television doing for India?
So what is it that you can look at 10 years from now? And I think that is the vision which should drive us. What is it in the whole area that 10 years from now is something worth doing, which we can see, and then we can start on it today.
Television and technology aided education is very much essential. We need to work out a proper mix of technology and how to use it.
Now the current trends are people want everything in their smartphone, one hand. So if DECO or ISRO wants to do something, how can you give that which people can take on demand?
And I would like to see that a television communication medium becomes a one pen drive like device connected to TV and empowered by the horizontal transmission of Wi-Fi on the smart city.
अब हम अपनी ये विशेष सभा आरंभ करते हैं मंगल ध्वनि से.
एक सोच ने हमें हौसला दिया, हौसले ने जज्बे को बढ़ाया. हमने मांगा लोगों का साथ तो उन्होंने मंजिल तक पहुंचाया. A vision of one ignited a few to unite the hands in hope and enlighten the hearts and minds of all. That's SITE for you. And that's what SITE is all about.
The technological system is a global one,
yes,
or a national
satellite.
one.
Yes.
Because without the local element in it and the local participation, the social impact will certainly be very much restricted.
It was directed to a future. And it was something which was visionary. It was not something that existed. That technology, when SITE was thought of and conceived, hardly existed.
SITE was avant-garde, it did it. So you have to be avant-garde if you want to take the spirit of SITE.
We did not change India, India changed us through SITE. ये सबसे बड़ी बात है।
ये छोटी आग से बड़ी आग बनती गई, थोड़ी चिंगारी से बड़ी बनती गई।